Finally, we are getting started with the real thing, guys. From now on, we are going to see all the essential Python libraries required for doing data science related tasks. Not only that, as we go through this Python journey, we are going to do amazing real world based projects that you can add in your resume too. So what are you waiting for? We are going to start with backbone of all the libraries, the godfather NumPy. In this video, you will find out what is NumPy, why do we use it, and how you can use it in your day-to-day data science related tasks. If you find this video helpful, hit that like button, subscribe to Data Decides, put your thoughts or any questions in the comment section below. Myself OMKAR PAWAR, your buddy in data science journey. So let's get right into it. Before we install NumPy, I want to tell you what is NumPy exactly and why do we use it. So NumPy is a Python library which was built for doing numerical calculations by using the Python language. So that's why it is named as numerical Python. So it is an abbreviation for that, numerical Python NumPy. NumPy is a backbone of all the essential libraries that we are using as a data scientist. Those are like pandas, matplotlib and seaborn. So what makes NumPy special? So why do we use it exactly? What are the reasons? Unlike Python, NumPy uses vectorized operations. What I mean by that, suppose you have a list and if you want to multiply all the elements inside the list, then what you will do? You have to loop over every element and then multiply and then again append it to the same list, right? Instead of that, what NumPy does is that it do element wise operations. So you don't have to loop. So that makes it more faster compared to Python lists. NumPy also have broadcasting ability. So what I mean by broadcasting is that when doing operations on the array, you don't have to worry about shape of the array. You don't have to do unnecessary reshaping of the arrays. NumPy is more memory efficient. As I told you, NumPy is faster with numerical calculations. And by using NumPy, we can do all sorts of linear algebra. What I mean by that, like we can create matrices, we can calculate eigenvectors, eigenvalues, solve linear equations, and for our data science work we can also do lot of statistical calculations. Talk about calculating mean, median, mode, standard deviation, correlation. We can check for hypothesis testing, calculating z-scores, percentiles, quartiles, detecting outliers, and so on. And one of the main features of NumPy is that we can do randomization by using NumPy. We can randomly generate arrays with random values within certain range. Randomization is very important terms when it comes to data science because we heavily use that when we are randomly sampling from our population data. So without further delay, let us install this NumPy library. So let's go into terminal. And inside the terminal you have to enter this command pip install numpy. So by using this command we will install our NumPy library in our system. You can pause this video and take your time. Okay, spelling error, pip install NumPy. So check if you are doing any spelling errors or not, because that may give you an error. So let's see if our library is installed or not. So let us import our library NumPy as np. So we are using np as alias. So instead of saying the writing the whole word, we will just write the np. So let us check like what version of NumPy do we have. Version. So this is my version of NumPy. You can check what version of NumPy you have installed. Now let us see how we can create an array inside a NumPy. So before creating an array, let me show you what I mean by vectorization exactly. So if I have a list here, let's say I have this L1 equal to 1, 2, 3 as its element. I have this list and let's say I want to multiply this by using the multiply every element of this list by number 2. How can I do that? If I try to do like this, it is not actually doing the multiplication it is just concatenating two lists together. And if I have to really multiply that, then what I have to do is that I have to use a for loop for I in L1. Inside that I have to use print. Let's say I will just print it with the I. Okay, so I have to do like this. I have to use a loop, then only I can multiply that list element with the desired integer, right? So instead of doing this, let me show you how we can do this by using NumPy arrays, and that too with more efficiency. So to create our first array, what we have to do is that we will use np.array, and inside that array we have to give our list. So we are giving L1 list and converted it into an array. So I will store that array inside one variable as array1. So let us see how this array looks like. So as you can see, we have converted our list into an array by using np.array. Let's say I want to multiply each and every element of this array1 by integer 2. How can I do that? I don't have to create any loop for this. I can simply use that array1, and I will simply write multiply by 2, and if you see the result, I am getting that result that I wanted. Each and every element of this array1 is multiplied by 2, and I am getting that array modified. I don't have to use a loop, and I don't have to use another, like in this case if I wanted to do something like change this, then I have to use lot of code. But by using the NumPy array, it becomes very short and very fast. So array also have other properties, such as we can check its dimension. What is the dimension of the array? So for that we can use ndim as a number of dimensions. We can check out the properties, and we can also check the shape of our array. In this case, this is just a one dimensional array, just like a list, and it is showing how many elements it have. It have 4 elements inside our array. Let me show you how we can create 2-dimensional or 3-dimensional array. So to create like 2-dimensional array, I will say array2 as a 2-dimensional array. We will use the same command np array, and inside that we have to create a nested list. Inside that I will write some elements. Again that I will write few more elements. So this way we create 2-dimensional array. So as we go with higher order or like higher dimension of the arrays, things become more and more complicated. Let me show you what is the shape of this array. I will print the shape. Okay, I will print everything here. Print array2. After that, so you can see we have successfully created our array, and we can also check the shape of our array. Shape of the array is 2 by 3, so that means 2 rows and 3 columns. As you can see, there are 2 rows and 3 columns. We can also check what are the dimensions of our array. N dimensions, number of dimensions. So it is a 2-dimensional array. But you observe one thing carefully, is that if our array is 2-dimensional, then we have its elements as a 1-dimensional array. So as we go further and further, let's suppose right now I create a 3-dimensional array of 3 dimensions, and inside that I say np dot array, and I created one list, and inside that list I will copy this 2-dimensional array. I will paste it inside. So 3-dimensional array have elements which are actually another 2-dimensional arrays. Inside my 3-dimensional array, I have 2-dimensional arrays as its element, as you can see here. If I try to print this one, let's see how it looks like. How you can tell this information? Like you can say is that, what you can say is that you can also check the shape first. Array3 dot shape, and the shape of the array 3, 2, 3. So how can you know, like if it is a 2-dimensional, then you can say it is like a 2 by 3. That means there are 2 rows, 3 columns. But in case of 3-dimensional array, what you can say? You can say it have 3 slices of 2 by 3 arrays. That means you have 3 slices. This is 1, 2, 3. 3 slices of 2 by 3 arrays. We can also change the shape of our array. How can we do that? To change the shape of our array, right now you have seen the shape of our 3-dimensional array. So what we will do, we will reshape it into, first we have to meet one condition. Like if you check how many number of elements do we have in this array 3-dimensional array, how many number of elements we have. So there are 3 slices, right? And there are 3 slices of 2 by 3 row. So you can check, there are total 18 elements are there, right? You can only reshape an array if your other shape is going to contain a same amount of element like the previous shape. In this case, if you want to transform it into another shape, then you have to make sure that you are going to contain all the elements inside your new array. So how can you do that? In this case, what we can do, we can shape it like this. So we can choose, if you want to store 18 elements, we can do like 9 into 2. That means if we do 9 by 2, then we can totally fit our 18 elements inside it. So if I enter the shape here, then if I hit the enter, then as you can see, our array have been reshaped. There is one more thing. If you don't want to consider like if you only know, like let's say I only want like I only know the first value for this, I don't know what is going to be my second value. So in that case, what you can do is that you can create a placeholder array3 dot reshape, and inside, let's say right now I don't know what is going to be my value for the row, and I only know like how many columns do I want. So I only want 2 columns, but I don't know how many rows I am going to require for that. So what I will do, I will say write -1 instead of the any value. So what is it going to do is that it is going to replace -1 with required whatever shape it is going to fit, which will contain the 18 elements. It will choose that value and it will reshape accordingly. If I do hit the if I run this cell, it will give me the same result. And I can also reverse this. If I do like this, if I reverse this, let's say I only know value for the rows and I don't know how many columns do I want. So it is going to create 2 by 9 array for us. So this way you can use this -1 as a placeholder. Now you know how to create an array by using the list. Now I want to show you, let's suppose we have one more array and we want to access its elements. How can you do that? So do that, we have to use indexing and slicing. So let me show you how we can do that. So for this purpose I will use one simple 3-dimensional array, np dot array. Okay, I have created my array. If you check the array, it is 2 by 2, a 2-dimensional array, and we have elements from 1 to 9 inside our array. Let's say we want to access all these elements, like particular elements as per our requirement. How can you do that? Let me show you. Indexing in array is very much similar to list. If I use my array and I have to write square brackets, then I will give the first index, like I will give the 0th index, and if I hit the enter, then I am getting its first element. So what I will do right now, if I write my array, then I will access my, let's say, row at a first index. And what I will do, then I want let's say I want the 5th 5 value. Then what I will do, I will use the 5 value is at first index inside. So I will say 1. If I hit the enter, I am getting that value. So first what I am doing, first I am accessing my first list. This is going to be the first list inside our array. If you don't know, like then let me tell you that in Python indexing starts from 0. So that's why I'm counting from 0, 0, 1, 2. It is going to be like that inside, and inside a row it is also going to be like 0, 1 and 2. So this way I can access this element. Now let's say I want to access 5 and 8, these two elements at the same time. How can I do that? So to do that, I can use my array. Inside that, first I will specify the data for the rows. So I will say 1 and 2. I want elements at first and second inside the first column, first index column. So I will say now 1. Now this will give me required elements. As you can see, I got what I wanted. So let's say if I want this 5 and 6, how can I do that? I can use the same technique here. Just I have to make some changes. Array, I will say, in this case right now I want elements from the this first row, right? Then what I can do, I can write as a first row, and I want first and second element, and if I hit the enter, I am getting it 5 and 6. As you can see, you can also do slicing in similar fashion. Let's suppose I want the same result but by doing the slicing. How can I do that? So to do that, I have to get the array, then I will write the square brackets, and right now I have to specify from which row till which row I want. Let's say I only want this first row, 0th row I mean, then I will write like this, and I will get the same result. So what is happening here, if you observe this carefully, indexing is giving us one dimensional array, and when we are doing the slicing, it is giving us two dimensional. So what I am doing here exactly? So what I am doing is that I am going for 0th row, and then I am going for the first column values for this one. So it is cropping like this only. This portion we are only getting as output. Now let's say that I also want like this same result. Then how can I get? If you check our array, so this is going to be 0, 2, and after that we want to go for 1 and 2, right? We only want 5 and 8. So how can we get that? By using the slicing. To get these elements, what we can do, we can say like my array. After that I will enter the details for the rows, from which row till which row. In slicing, the index that we are going to choose for end, it is not included, so it will only give us first rows at first and second index. So for the column also, what we will do, we will choose the first and second. We will only get the values at first column. Let's say what we are getting as output. So as you can see, we are getting the similar output, just the dimension, it is two dimensional. How can I do this? Let's see how can we do this. So my array, inside of my array 2 and 1, 3, I think this will give me the results. If you are getting a little bit confused, don't worry, I have created one diagram for you that will help you to visualize these things, how it is going to work. Let me show you that diagram so you will have a better understanding. If you check, I tried to use the same commands as above, so you can visualize that here. If you still feeling little bit confused, then you should have to try it once, then you will get grasp of it and you will understand how things are working exactly. And I am sure that this chart will help you. Till now we have only seen how we can create an arrays by using a list. That means we are doing it manually. What if we randomly generate its element? How can we do that? By using the NumPy. So for that we will use NumPy's randomization module. So let me show you how we can do that. So if I write numpy.random, so I'm accessing into random module and I'm using rand, and after that I'm giving I can give values like, let's say I want 10 randomly generated values, so it will give me 10 randomly generated values. Or let's say random.rand, and I want an array with a different shape. Can I get that? So yeah, definitely I can get that. Let's say I want an array of this shape. then I am getting a randomly generated array, and its values are going to be between 0 till 1. Similar way, we can also generate values which are normally distributed. So what I mean by that, let me show you. I will use np.random.rand, and I will just use n. That means the array values that we are going to have inside this array, these are going to be randomly generated, but its distribution is going to be normal. So if I do like this, and then I'm going to get a result. To visualize this, I can create a graph using matplotlib. I have not created any video on this. If you want to see video on matplotlib also, so I request you to subscribe our channel, hit that like button, and share our video with your fellow data buddies. Don't get overwhelmed by this code, because I am going to explain the matplotlib library in our next video. So just hold on to this, and I will show you like how it is creating normally distributed and just in general. So if in this first case, what I will do is I will create np.random.rand, only randomly generated, it is not normally distributed, right? So what I will do, I will create 1000 data elements inside our array, and I am passing it into data for histogram. Okay, and I will do something similar here also. I will do np.random. Just in this case, I will create a normally distributed data. So this way it will be more clear to you. If I run this first one, you can see the data is not normally distributed. And in the second case, when I am using rand, and that means randomly generated but normally distributed, so it is going to be a bell shaped. I hope you got my point. So let me tell you one more interesting concept. np.random.rand, and inside that I will simply say, let's give me only five values, 5 elements. So observe this data. If I copy this same command and if I run it again, what is going to happen? I am not getting the same elements, right? Because it is randomly generated. But let's say that you want a randomly generated array, but at the same time you want to reuse it somewhere else in your code. How can you do that? So to do that, there is one method, np.seed. So if I use that, let's say I will copy this again, and let's say this time I want only 3 elements. Okay, and but in this case, what I will do, I will use np.seed. I have to access into random module, and inside that I have to go for the seed, and I have to give any arbitrary number. Let's suppose I give 25 here, and if I hit enter right now, and if I hold on, I will write this after this command, so it will print it. I don't have to use the print. And let's say, what if I use the same thing here again? What am I going to get? I have to use the seed again. If I use along with this seed, let's see what is going to happen. I am going the same set of elements for the arrays, even I am generating it randomly. So this seed acts as an anchor, so it holds on to these values. So if I create like a 5 or like 5 or let's say 6 randomly generated values, and in this case also I do 6 randomly generated values, so both of these randomly generated arrays are going to be same, and the number that you put inside this seed it can be any number. If you have observed something carefully, we are only getting values from 0 to 1. What if you want integers as your randomly generated values? So in that case, what you can do is that you can use np.random.randint, and inside that you have to give the lowest number. What is the range? You have to give the range here. So lowest number I want 0, so I want from 0 until the highest one will be let's say 9, and I want, like, you have to give the size, for what size you want. So it's basically the shape. So what you want is that, let's say I want 3 by 4. So let's see what we get. So I am getting a randomly generated array, but the values inside, these are all the integers. By using NumPy, we can create a range. Let me show you how to. So to create a range, we will use np dot array range. Inside that, we have to give the starting point from which point till which point. So for starting, I will give 0, and for stopping, that means where to stop, I want it to stop at let's say 10, and after that I can also give the step value. So for now I am giving a step of 1. Okay, so let's see what we get as output. So we are getting a range starting from 0 and it is going till 9, because whatever we give as a stop point is not included, it is excluded. And if I change the step here, if I copy this, you already know because we have seen this inside the list also. So I am getting a step, like it is stepping, it is skipping one element here. From 0 it is directly going to 1 2 at second position, then again 1 2, it is like that. It is stepping over one element. So why it is necessary? Because we also have range in list, right? But why again have this in NumPy also? So the reason is that we cannot create a range if we are starting with, like, let's say a float value. If I enter here 0.5 and if I hit the enter, I will get my results. But instead of this, let's say I copy this as a range, and if I paste it here, and if I run this, it is going to give me, inside a range I will create a range from, let's say 0 till 10. Okay, then and I will convert it into a list. So let's see what we get. So we are getting a list here, right now we are not getting any error. But what if I do here 0.5, and now if I try, so it is going to give me a float typing error, right? So but inside a NumPy we don't get any kind of error. Let me tell you about one case scenario. Let's say that from range 0 to 10 I want, let's say 20 values, and then how can I get that? So to do that, let's say I use np dot line space. To achieve that, I will use np dot line space, and inside that I will give starting point from where to start 0, and I will give stop point, stop at 10. After that I will give a number, like exactly how many values do I want between this range. So let's say I want 20 values, and if I hit the run, okay, there is one extra. Okay, I'm getting 20 values between the range of 0 to 10. If I want to know, like, what is the step, what is the rate step, then what I can do is that I can enable rate step equal to true. Then I will get also the stepping at which rate. What it is doing exactly is that it is adding this rate step value inside the starting point over the, like, 20 times. So we are getting all the values as per our requirement. Now let us see how we can do some basic arithmetic operations on these arrays. So I will create, so as you can see, we have created two arrays. Now I will show you how we can do this arithmetic operations. I will quickly show. You can do the addition, array 1 plus array 2, and it will simply do the addition element wise. It is adding 7 plus 3 10, 4 plus 4 8. It's like that. So the same thing will happen with subtraction also. Same thing is happening with the subtraction, right? 3 minus what is there, 7 minus 3, we are getting 4. So it will happen element wise. And if we do the multiplication, a1 multiplied by a2, so it is simply multiplying. It is multiplying in this case 7 into 3, that is 21. So same way it is across the array, it is multiplying that way. But there is one more different way to multiply, that is matrix multiplication. So that is little bit different thing. How you can do that? Instead of star sign, you will use at sign here. So this will be a matrix multiplication. If I show you here, now this one and this one is a little bit different. In some other video I will show you how this is happening exactly. Now we will see how we can do some statistical calculations by using NumPy. So I have created this data, okay, and on this data we will perform like some statistical calculations. So I will try to find what is the mean of this data. So to do that, I will use np.mean and I will provide the data. Now it is giving me what is the mean value. After that it can give me the median also, and I have to provide the data inside it. So as you can see, I am getting mean and median. You can also get percentiles here. You can get value like quartiles also. How can you get that? Like you can get what is the value at 25th percentile, 50 percentile, that is nothing but a median, and 75 percentile. So you can understand like the data distribution more better way this way. So we will use np dot percentile, and inside that we will provide the data, and we want 25th percentile, 50 percentile and 75 percentile. So if I hit the enter, so we are getting the values. So as you can see, at 50 percentile it is the same as the median. The value is same as the median. I can also find variance of our data. I can also find standard deviation, np.std for standard deviation of our data. By using variance and standard deviation, you can understand the how much is the spread of our data. In our machine learning projects, we have sometimes lot of features. So what we try to do is that we try to find the correlation between two features. If the correlation between two features is very high, then what we can do is that we can simply drop one of them feature. So it makes our machine learning model more memory efficient because it have to handle little bit less number of features. So let's see how we can calculate the correlation between two arrays. I have created these two arrays. So let me show you quickly how can we find correlation between them. So to find the correlation between them, I will use np.correlation coefficient. Then what I will do, I will give the first array, array 1, and after that I will give array 2, and then I will hit the enter. As you can see, I am getting a positive correlation here. As for starters, I feel this knowledge of DOS is more than enough for you to getting started with NumPy. So I hope you found this video helpful. If you do, then hit that like button, subscribe to our channel Data Decides. Stay tuned for more future updates. We are going to talk about other libraries including Pandas, Matplotlib, Seaborn and many more. Thank you for watching this video. Myself OMKAR PAWAR signing off.